Hey guys, welcome to video 2 of the unit circle series, where we will be going over the unit circle. Today's focus for this lesson is going over the degrees and the coordinates of quadrant 1. As a reminder, in each of these videos, I will be giving you a full breakdown and explanation of what we're going over. I'll also include some downloadable notes so that you can print those off and do the math alongside with me. And then at the end, there will also be check your understanding questions, which you can pause the video, try those on your own, and then compare to see if you're getting them right. Before we start with this lesson, we just want to recap what we went over in the first video. That first video included information about the series overall, and then just some initial information about what the unit circle was. So as we see here in this picture, the unit circle is just a circle centered at the origin at 0, 0. And the length of the radius is 1. Then what we talked about is that if we look at the unit circle, there's these dots which represent coordinates on the unit circle. And if we zoom in closer, we see that there's actually some other coordinates that we need to find the locations for. Our focus today for this video is looking at the first quadrant. And the first quadrant is just this upper right section of the unit circle. With all that in mind, we're going to go ahead and get started with the notes now. So we're going to start with this warm-up. It says number 1, we're going to write the side length of the base and the height. My base length is 3 and my height is 4, so I'm just going to write those numbers here. Step 2, we're going to write the coordinates of point C. So point C is located right here. And so we're just writing the coordinate. So that's going to be 3, 4. And so I can write that on the line right here. And then for step 3, we need to find the length of the hypotenuse. You may already know what this is, but just in case, we're going to find it with the Pythagorean theorem. So we're going to do a squared plus b squared equals c squared. And so now my a side is 3, so I'm going to write 3 squared plus the b side is 4, so 4 squared equals c squared. Once I start simplifying that, I'm going to get 9 plus 16 equals c squared. And from that, c squared is going to equal 25. And so to find c, we're going to take the square root of both sides. And I'm going to get c equals 5. So that is going to be the length of my hypotenuse. If we look at this next section, it's the same triangle we just graphed, but now it just has a circle around it. So what we're going to do is just write our base and our height again, 3 and 4. And then what we basically did was we used those to find the coordinate. So from 0, 0, our value was 3, 4. So basically what we see is that our base length from 0, 0 is 3. That's our x value. And the height is 4. So that's our y value. So our base is x and the height is y. So our coordinate is going to be represented using x, y. And so the hypotenuse length that we found was 5 from doing the Pythagorean theorem. And what we also want to see is that the radius of this circle, the radius is from the center to the circumference to the outside, all the length around the circle is going to be 5. So that is what we are using as the hypotenuse length. Whatever the radius of your circle is, that's the hypotenuse that you're using. What we're going to do now is start with using our special right triangle rules. So the missing angle for this triangle is 60 degrees. So I have a 30, 60, 90 triangle. And so the rule to get from the hypotenuse to the short side is to divide by 2. So I'm going to write 1 divided by 2. And I'm just going to leave it as a fraction, so I'm going to leave it as 1 over 2. And then to get from the short side to the medium side, what I'm going to do is multiply by root 3. And so what I'm going to write is 1 over 2 times root 3, and I'm going to put that over 1 just so we're multiplying the numerator and the denominator by something. When we multiply, we're going to leave it as 1 times root 3, so that's how that would be written. And then the bottom, 2 times 1 is 2. So now, for our final answer, we don't have to write the 1. We could just leave it as root 3, and then I'm going to leave the 2 the same. So I get root 3 over 2. For my next triangle, that missing angle is a 45-degree angle. So right here we have a 45, 45, 90 right triangle. To go from the hypotenuse to either leg, I'm going to divide by root 2. So whenever I do that, I'm going to divide the hypotenuse, 1 divided by root 2. And what we have to do, since we have an irrational number in the denominator, we have to simplify that. It's called rationalizing the denominator. So we're going to multiply the top and the bottom by root 2, whatever the radical is. Root 2 divided by root 2 is just 1. So we're not changing the value of this fraction because we're just multiplying by 1. But what this allows us to do is get rid of that radical in the bottom of the fraction. So whenever I do that, on the top, I'm going to get 1 root 2. And then on the bottom, whenever I multiply root 2 times root 2, that is going to equal root 4, which simplifies to just whole number 2. So now that radical is gone from the bottom, and then we just have root 2 on top, and then whole number 2 on the bottom. So my final answer would be root 2 over 2. And since this is a 45-45 isosceles right triangle, I know that my side lengths are going to be the same. So both of those legs are going to be the same number. And so now for my last triangle, this is also a 30, 60, 90 triangle, and the hypotenuse is a length of 1. So right here, these are the same triangle, it's just kind of rotated. And so I don't really need to do the calculations again. I can just match up side lengths. So what I'm going to do is I'm going to highlight this side. It's going to match up with the base of this triangle. And then this base on the left triangle is going to match up with the height on this right triangle. So now all I have to do, instead of doing all the math again, is I can just rewrite these numbers. So I get 1/2 for that side length, and then root 3 over 2 for that side length. So those are our right triangles. And what we're going to be doing is using these triangles to graph them onto the unit circle. So this first one is going to go with this triangle. The second one is going to go with this one. And the third one is going to go with this one. We're going to graph this triangle, and the first step is to label the length of the hypotenuse as 1. So I'm just going to write 1 right here. And the question then says, why is the hypotenuse 1? And that's because the radius of the unit circle is 1. So that's why we're using it as our hypotenuse length. Just like on the 3, 4, 5 triangle, the hypotenuse was 5, so was the radius of that circle. So the distance around this circle is going to be 1, radius-wise. So next, we're going to write the side lengths of the base and the height. And so now we can look at these triangles that we came up with and see that we're just going to be using the first one that or the one on the very left. And so my hypotenuse for both of those is 1. And then the base angle, or theta, that we're using is 30 degrees. So I'm going to match up my side lengths. This height matches up with this height, and the base matches up with this base. So now all I need to do is write those side lengths where in the height and the base. So my base is root 3 over 2, and my height is going to be 1/2. And so those are just going to be the x and y values that we get for our triangle. So what I'm going to do now is write x comma y. And remember, our base is our x value. That's the length that we're going across. So that's your x. The height that you get is your y. So now I can just write those values. And I'm going to get, for my coordinate, root 3 over 2, comma, 1/2. And so for number 3, that would be what we write on those blanks, root 3 over 2, comma, 1/2. Just to recap that, this is what that looks like. So what we did was we graphed a 30, 60, 90 right triangle. The theta angle that we used was 30 degrees, so that's here. We found the coordinate, the x comma y, using the base and the height of our triangle. So the base is your bottom side, and then the height is the rise part. So our x value is root 3 over 2, and our y value is 1/2. The hypotenuse that we used was 1, and that's because the radius of that circle is 1. So that means from the center to the circumference of the circle, no matter where I go in the circle around it, the length of that line is always going to be 1. So that is our radius. So now we're going to do the same thing with the 45-degree triangle. So I'm going to label the hypotenuse as a length of 1. The reason we're using 1 as the hypotenuse is because that's the radius of the circle. So from 0, 0, if we just move 1 around, it's always going to be the same distance. Now we're going to write the side lengths of the base and the height. And so this time we're going to be using that middle triangle that we found. So our base length, or our hypotenuse, is going to be 1. Our theta is going to be 45 degrees. So that's why we're using the middle one. My height is going to match up with that height. And then I'm going to match up the base with this side of the triangle. And so both of these legs are the same length. So I'm going to go ahead and write those values there. I'm just going to erase this so it's a little less cluttered. And so my base is root 2 over 2. The height is going to be root 2 over 2. And so those are going to be our x and y values. So this is my y, this is my x. And now I can write the coordinate as x comma y. And I'm going to get root 2 over 2 comma root 2 over 2. And so for number 3, I can write those as the coordinates of point C. To recap, we graphed a 45, 45, 90 right triangle, and our theta angle that we used was 45 degrees. And so then we were able to find the coordinates using the side lengths of the triangle. So both of these had the same length for each leg. So the values for the x and y are going to be the same. And then the reason that the hypotenuse was 1, because the radius of the unit circle is 1 unit long. So we're going to do this one more time. So we're using the 60-degree triangle this time. The length of our hypotenuse is 1. The hypotenuse is 1 because that's the radius of our unit circle. The next thing we're going to do is write our side lengths of our base and our height. So we're going to look at which triangle we're using. This time it's the one on the very right. That's going to be the 60-degree triangle. The hypotenuse are both 1, and the angle that we're using is 60 degrees. So that is why we're choosing this triangle. Now we can match up our side lengths. So I'm going to match up my height and my base together. And then now I can actually write those measurements. So I'm going to erase this, and my base length is going to be 1/2, and my height is going to be root 3 over 2. Just like before, those are going to be the measurements or the values we use for our coordinates. So my x and my y values. So now I'm going to write x comma y, and I can just fill in those numbers. So the coordinate for this location is going to be 1/2 comma root 3 over 2. And so for step 3, you just have to write the coordinate pair. So here's what that triangle looks like on the unit circle. Our theta degree angle was 60 degrees. And so now we were able to find the coordinate using the base length and the height. So our base length was 1/2, and our height for this triangle is root 3 over 2. So that's where we got that number. And then lastly, our hypotenuse was 1 because of the radius of our circle is also 1. Now you can see why it was so important for us to find those values initially, is because it allows us to find the values for each of these 3 triangles when they're graphed on the unit circle. So each one's going to match up with 1. And remember, our base length is our x value. So base is going to be the x. The height is going to be your y value. So now what we're going to do is write these values for x and y on each triangle. So now for the 30-degree one, I'm going to put that on this triangle. So that's going to be root 3 over 2, comma 1/2. The next triangle is going to be root 2 over 2, root 2 over 2. And then for my last triangle, I'll get 1/2 as the x value, root 3 over 2 for the y value. What we're looking at is quadrant 1 of the unit circle. Quadrant 1 is just this upper right section. So when we're graphing, remember, the unit circle is just a tiny circle at the origin. So we're just doing this one little piece in quadrant 1. So now what we're going to do is just label all this. So remember, my center of my circle is at 0, 0. So that's in the center of the graph. The radius, or the length from the center to the most right point, is 1. So that radius length is going to be just 1 unit. So if I move over 1 unit, that means that I'm just putting a dot here at 1, 0. So if I look at my mini graph on the right, that's where that dot is. And so now if I go up from 0, 0, just 1 unit, that would be at 0, 1. So I'm going to put a dot on my mini graph right here too. And so if we zoom in, those are the 2 points that we graphed. So the quadrant 1 that we've done so far is just this little section with those 3 dots. So now what we're going to do is just go ahead and write our values. So this first one that I'm graphing is the 30-degree one. So right here, this line is measuring the hypotenuse of that 30-degree triangle. The line I just drew is the height, and so the length from the center to where it meets would be the base length. So that is the 30-degree angle from the base to that hypotenuse. That's 30 degrees. So now I can just go ahead and write my coordinate value. So I'm going to write root 3 over 2, comma 1/2. And I can do the same thing with the 45 degree angle now. So I'm going to draw this as the hypotenuse. So that green line I just drew is 1. The line that I just drew now is going to be the height. We don't need to draw that height line, so I'm just going to erase it. But I do want to draw this angle measure. So from the base of that red line up to the green line, that's 45 degrees. So now I'm going to write the coordinates of root 2 over 2, root 2 over 2. And so we just have one more triangle to do. So I'm going to do my my 60 degree angle now. I'm going to do this one in purple. So that purple line that I just drew, that's the hypotenuse. That's a radius of 1. And so then that line that I drew straight down, that would be the height. We don't need that, so I'm going to erase it. And then now this curved line, that's the 60 degree angle from the base to the purple line. That is 60 degrees. So my coordinate would be 1/2, comma, root 3 over 2. And that is our quadrant 1 of the unit circle. Just to formalize this all in some notes, what we did was we graphed a unit circle. A unit circle is just a circle with a center at the origin, which is 0, 0. So I'm going to put that on my picture. A unit circle has a radius of 1 unit. So that means from the center to this point right here would be 1, and it is a length of 1 all the way around the circle. The unit circle coordinates are going to be found using special right triangles. So that would be your 30, 60, 90 triangle and your 45, 45, 90 triangle. And so the length of the hypotenuse for all those was 1. So the hypotenuse of each triangle was 1. And that's our theta angle that we're using for each of the special right triangles. The radius of the unit circle is also 1. So pretty much all those lengths are just 1. And so what we want to do now is go ahead and put the degrees. So if I don't move up at all, if I'm not moving up at all, that's just 0 degrees. But so if I go across, the coordinate value is 1, 0. This first line, if I move up just a little bit, that's 30 degrees. So this would be my 30 degree coordinate. And then the next one, if I move all the way right there, that's 45 degrees. So this is my 45 degree coordinate. And so those values are root 2 over 2 for both. And then my last one is my 60 degrees. So if I go from the base, basically, all the way up to that line, that would be 60 degrees angle-wise. And so my x value is 1/2, y is root 3 over 2. The last one we need to write is going to be this coordinate. So that is a 90 degree. Think about if you're rotating all the way like 90 degrees counterclockwise or whatever, that's just going to be 90 degrees. So that would be straight up, and that would be at 0, 1. So right here is the check your understanding questions. Remember, you can print these out from the link in the description, or you can just try them on here. I would pause the video and try them on your own, and then press play when you're done so that you can see if you're getting them correct. So what we're going to do to start is just pretend that we forgot what the numbers are. So just quickly go back over how we got these. So we're going to divide by 2 to get 1/2, and then I'm going to multiply that by root 3. When I do that, I'm going to just get root 3 over 2. For my next triangle, I'm going to know these are the same length, so I just need to get one of the sides. So I'm going to divide by root 2. When I do 1 divided by root 2, I have to rationalize that denominator, so I'm going to multiply both by root 2, and then I'm going to get root 2 over 2 for my side lengths. And then for my last triangle, I know this is the same as the other triangle, so I just have to put the measurements in the right place now. So I'm going to have 1/2 and then root 3 over 2. All right, for number 2, we didn't actually do this, but it's just application type stuff. So we want to prove that the hypotenuse of each triangle is a length of 1. So we're going to use Pythagorean theorem. And proving in this case, we're just going to make sure we show our work for all the steps. So I'm going to use my first triangle is the one on the left. So I'm going to do my A side is root 3 over 2 squared, plus the B side is going to be 1/2 squared, and then that's going to be equal C squared. So whenever I do this, I have a exponent on the outside of a fraction. So I have to distribute that to both the numerator and the denominator. So when I do that, I'm going to get root 3 squared over 2 squared. And so whenever we simplify this, basically what this is going to equal for just this first fraction, my denominator is going to be 4. And my numerator, I have to do root 3 times root 3, that's root 9. which is just going to simplify to 3. So we're going to get 3 over 4. For my next one, I'm going to distribute it again. So I'm going to get 1 squared over 2 squared. When I simplify that, I get 1 over 4. And then when we add fractions, we add the numerators but keep the denominators the same. So I get 4 over 4, which equals 1, which is the length of our hypotenuse. So for this one, that is that problem, but technically it's also going to be the one on the very right. The numbers are just going to switch places, but that's still going to equal the same thing. So we don't need to test that one again necessarily. But we're going to go ahead and test the other one. So I'm going to do root 2 over 2 squared plus root 2 over 2 squared, because we're doing a squared plus b squared equals c squared. And so I'm going to get the denominator is going to be 4 in this case, and then whenever I do the numerator, I'm going to get root 2 squared equals 2, because root 2 times root 2 is 4, or root 4, which is just going to simplify to whole number 2. So I get 2 plus 2 is 4, and then that's going to be 4 over 4, which is 1. The square root of 1 is just 1. So in both cases, c squared is 1, which means c is going to be 1. All right, for this one, we're just giving the angles, or we're given the angles and writing the coordinates again. So this is just to help you repetitively practice putting these coordinates there and understanding that they're coming from these 3 right triangles. So those are my values for all of those. And so now for the next section, oh, I also want to put x, y under here just so you're kind of aware of that. For the next section, we're going to write the coordinates and the degrees of them. And number 2, we're going to write the coordinates of the 2 remaining points. So I'm going to put 0, 0 here just so we're aware that's the origin. And I can go ahead and put 1, 0, and 0, 1. And then I'm going to write all my coordinate pairs really quickly. And so this is my last one, 1/2, root 3 over 2. The next thing I want to do is write my points. So if I move over to the left 1, I'm going to get like a point right here. If we were to just graph that point, which is what this circle has graphed, that's just going to be at -1, 0. So that is the point on that unit circle if we move to the left 1. If I go straight down to the bottom, I'm going to get this green point right here on a regular graph, which is what the unit circle is graphed on. That's going to be 0, -1. So that point is at 0, -1. So now I can go and write those points. So -1, 0, and 0, -1. What we'll be doing in the next video is looking at the full unit circle. So we'll be looking at all the degrees and all the coordinates that we have to know. So I hope you found this video helpful, and I hope to see you in the next one. Thanks for watching.